concepts, right? The data dimensional modeling, we spoke about three type of schema: star schema, snowflake schema, and what is that? Fact- Sorry, galaxy schema, correct. And on the slowly changing dimensions, okay, we spoke about SCD1, right? SCD1, yeah, 2 and 3. Okay, so you guys understood, right? All these SCD1, how we are maintaining the history, okay, and SCD2, how we are doing the like maintaining the history, and SCD3, how we are maintaining the history. Okay, now let's go to another concept. So we have the different type of modeling. So this all right, we don't perform, okay, as a tester we don't perform, but at times we might need to test it, okay. So it is good to know this data model will be built by data modeler. Okay, there are different roles each one plays as in when the project will start off. Okay, so I will tell you. So there will be a customer, okay, client or customer. He actually has a problem. Okay, problem in the sense a problem statement we can say. Okay, and now he is looking for the solution. So now next what happens is basically this guy. There'll be a BA. So BA is a person who understands the problem statement of business and translates them into technical requirement. Okay? That's the role of BA. Okay. So he'll be in constant communication with the client. So this would be a two-way communication. Okay. So it would be like this. Okay. Next, what happens? So once this guy is understood the problem statement, he will start building few documents. Okay, so he will start building few documents that is important for the technical team to proceed. Okay, those documents are those documents are this. I'll give you that list. Okay, so he will build the BRT, that is business requirement document. Then he'll give the FSD also. So it is functional specification. Either both are same, but depending on project they'll go. Okay, and he'll build the data mapping document. Okay, data mapping document. So just be aware of the documents he will build so that I can explain all these in the upcoming classes. Okay, he will build this. Also, he will build the expected results. Okay, and what else he'll build? Yeah. Okay, got it. No, these documents he will build. After he builds these documents, what happens is these documents are given to the developer. Okay, so let's take this flow back here. See, this is basically how you build a product, software product. Okay, so this is given to whom? This is given to the IT team. So for folks who joined no just now, I was just talking about the different roles. So how do you build a software product? There are different steps in building a software product. First, the client or the customer who runs the business, he has a problem statement, and that problem statement will be communicated to the business analyst, and the business analyst would have sessions with the client to understand the problem statement exactly, and then he translate them into a technical requirement document. Okay, that business will be translated to technical requirements. As part of this translation and building the technical requirements, he will be building all these expected documents. Okay, a BRD where it contains the business problem statements, FSD it contains the functional of all the system. Okay, the data mapping document, this will contain the flow as to from where the source is coming and to where the target will be flowing, and expected results for the logic which he has built. He will apply the same logic manually and come up with the expected results. Okay, after that these documents are handed over to the IT team. Okay, so when I say IT team, who all comprise IT team? Okay, so there'll be multiple folks in over here. You can call them a technical dev team, development team. You can call the QA team, and there'll be deployment team. There'll be deployment team. um, Even a DBA or a database administrator or a data modeler. Okay, all come under IT team only. Okay, but the roles will differ. So what happens, say for example in this requirement we have a report. Okay, where date of birth is available, and now you want to calculate the age for that report. Okay, for that particular date of birth, and you want to show that in the report. So as a first step, what the after once the business requirement is received here, the database administrator will check if the tables are available. Okay, in the database. So for folks who don't know what is database and all, right, you will know slowly, but just know database is a storage. Okay, where we store the data and there are tables like I showed you in Excel. No, so like this is also called a table. Okay, it consists of rows and columns. So horizontal is called rows and verticals are called columns. In this case there are two columns and 1 2 3 4 5 6 7 8 rows, out of which first one is header, so 7 rows of data. So it's like that. This is how it is stored in the database also. Okay, now my requirement is to add a age column. Consider there is a date of birth already available and you need to add a age column. So the DBA will first check if this table is available, and then he will create this new column in the table. Okay, and then the corresponding data, right, it should be numbers. So those numbers are he'll define the data type. So data type is something, it is what it defines basically to store what kind of text. Say for example, if you need to store text, there are different type of data types. There are numeric data types, there is a character data types, a varchar. Okay, varchar 2, you have the float, you have the decimals. Okay, all this. Suppose if you want to store a whole number without decimals, you can use this. So age will be defined using numeric data type. And character varchar. Okay, varchar, character, varchar 2, all these are actually storing, all these are actually storing text. Okay, float and decimal will store the decimal points like numbers like 1 to 1. Okay, When you try to store this float into this, the decimal part will be truncated. Okay, the decimal part will be truncated. Okay, so this is a basic idea on data types. When I explain the SQL, no, I'll explain you in depth. For now, consider the requirement is to calculate the age. Okay, so the DB guy, the DB guy, okay, will create a column, and data modeler will actually see the whole model and see where this table is in, is there any keys associated with it. He'll try to build the relationship. Once everything is in place, the developer will actually use the ETL tool. So there are different ETL tools, like I told you: Informatica, Ab Initio, Data Stage, SSIS. Using these tools, they will apply some logics. The logic is fairly simple. The current date, this logic would be the current date minus date of birth. Okay, this will give the number. So you'll apply that particular logic and load that into the target table. Once the development is complete, what happens basically is, once the development is complete, they will move to QA team. Okay, so we will come here. Okay, ETL testing will come as part of QA team. So here all the testers would be available. They'll start testing the application and see if everything is working as expected. Okay, as whatever is mentioned the BRD, it is the same. And once the testing is complete, okay, without any errors or bugs, okay, then they'll give a sign off, and then development team again coordinates with the deployment team and push that into production. So this is the entire process. Okay, so there are different regions. You have the dev region, you have the QA region, you have the UAT region, and you have the prod region. So this place is where, okay, this box is basically used by developers. This is used by testers. This space is used by testers. This is used by users. Okay, users are nothing but like proxy customers. So every business will have proxy customers who has to test the application from business perspective. Like, for example, they'll play of a role of a customer outside the bank and see if a customer tries to use the application, what all the scenarios he will validate. And finally, prod is nothing but live data. Live data. Okay, so before prod there can be alpha region, they can be beta, they can be gamma also. Gamma. Okay, so these are all simulations of production. Okay, before moving here they'll test here for 3 months or 1 month, then after that they'll move here. Okay, this and all three setups will be same. Okay, will be the same. So after they get confident that everything is working fine and it is not breaking anything, then they'll move to prod. Prod is live data. Okay, when you say production data, it means the data that is already running live. For example, if you go to the ATM, no, what happens when you pull out like, some cash? Okay, there are automatically logics that are written behind, okay, at the back end, which will run and it will give you the amount you withdrawn, okay, the available balance, the account number, all that details, right? So that current data which is already in live and running is called production data. So you should be very careful not to mess up with the production data. If you mess up with the production data, you are directly hitting the revenue of that particular business. Okay, I'll take a pause. You can ask questions. The roles are different. Both would be dealing with database. But a DBA modeler, right? He will model the database. I'll show you that. But a DBA, database administrator, will he's an administrator to the database. So he's the one who will be providing access, creating new tables, creating new columns. Okay. So if I show you, see, this is what data modeler builds. So you remember, so he'll be modeling the entire system. So these are three steps which he follows. First, he'll build the conceptual model, then he'll build the logical, then this physical model. So this is like a blueprint. Okay. And once he builds the physical model, this is what is given to the database administrator. He will go ahead and create the tables with the names and columns and data types that is mentioned. Yes, yes. But he has to have an understanding of functional as well. Yeah, because he should know, if he knows the business well, he'll be able to relate, build relationships between the facts and dimensions. Okay. So this is self-explanatory. Okay. If you see here, differences are simple: conceptual, logical, and physical. This box, if you know, yeah. For QA, what creating and updating tables is it? DBA. Hmm. Yes. See, joining and all, it's a different concept. Okay. Based on the requirement, anybody can join. Okay. But making sure the database, see, database is taken care by database administrator. He is like a supervisor for the database, in charge. Okay. So if you want any access, okay, if you want to create any tables, you want to create any columns, you have to talk to the database administrator. Okay. In few projects, database administrator and data modeler both is handled by one single person only. They'll club it. Okay. Any other questions? So you guys understood, right? How the problem statement, how the product is built, what are the steps that's happening. Hmm? Now coming back to data modeling, right? You have three: conceptual, logical, and physical. I told you. So these are the feature, and whichever is applicable, they have just ticked it. So in conceptual, only entity names and relationships are defined. So entity names is nothing but your table names. Only table names are known first. Okay. First they'll come up with the table names and they'll establish relationship. Correct. Next, what they do after conceptual, they go for logical modeling. In logical, already these two are covered. Okay. Now they come up with attributes, primary keys, and foreign keys. So you see here, from here to here, this name remains the same, right? What is done is they have added attributes is nothing but your field names or column names. So they have added, and also whatever you see on top right, this one within this small box, rectangle box, this is these are the primary keys. So for time dimension, These are the columns that are available, and date is the primary key. For product dimension, these are the columns that are available, and primary key is product ID. So what is the primary key? Primary key is a column in a table that uniquely identifies a row in a table. Okay, I'll show you all that, but for now just understand this. So from after they build logical model, next step is they have to fill the physical model. So what they give the exact names that has to go into the database, as well as they give its particular data type. Rest all is remains the same. So now they are saying this time, this entity now, you have to create this time entity name as dim underscore time in the database. So when you go into the database, you have to refer this physical model design. Okay. Date ID is integer. Date description is varchar. I told you it stores only text. Month ID is integer, which store only whole numbers. Month description is text, which stores. It's a varchar. They have defined which stores text of length 30. Okay. Within the brackets, whatever they have mentioned, no, that is the length for the text. Likewise, you understood. So after coming here, they'll again define the table names, column names, and data types. What guys, understood? This is good to know. It's not, we cannot leave that out, but we cannot say very important for us or not important also. This is must know concept. Any doubts? Can someone want to explain this small model? Don't mind if it's wrong also, just give it a try. You don't have to revise again if you do all this. You'll remember. Do you want to go, Tejasvi? Data modeler. Yeah. Three levels. Yeah. So one by one they build. For example, right, I'll tell they are build constructing your house. So you can think of that. So what they do first, they design a small blueprint. Okay, they design where should be the bedrooms, where should be a living room, where should be a balcony, where should be a foyer area, all that. Then slowly they come up. Okay, and they'll give a detailed description of all this. So in bedroom, the dimension should be like uh, 10 by 12. Okay, and the tiles should be all this. Okay, the fitting should be this. Okay, the hall dimension should be uh, some dimension, whatever dimension, and the paint color, all that. Yeah, more detail they would go, I'll say. Okay, but when they come to physical, they actually give the they define the actuals. Say for example, they define this date id, okay, to be integer. Here it is just date. Okay, but this is what will be going into the database. Understand? So just take a look at this, guys. You will understand. First they define the entity names and relationships. So take a look at this diagram. Entity names and this relationships is this arrows. Next, they define attributes, primary keys, and foreign keys. Okay, this is done. Next, they go here. They define the attributes, field names. Okay, the relationships already done, and the keys. Next, what they do? They define the table names. Entity becomes table name. Attributes become column names. They have the data type and length. Got it, Tejas? So what do you find the difference between physical to? Okay, okay. So what I'm saying is, first they will build attributes, first they'll build entities, they'll build relationships. Okay. See, those are the keywords. Okay. Those are the keywords in, or technical terms in database. Okay. First they build attributes. Okay. Then they build relationships. Then this attributes, right? They'll give a details of this attributes. Sorry, entities. I'm sorry. First they'll build entities. Once entities are built and relationships are established, for this particular entities, they give attributes. So these are technical terms. You have to describe the same way I'm describing. So these are now called attributes. Okay. And now when they move from logical to physical, what happened? These entity names will become table names. Okay. These attributes will become column names. Okay. And this is the data type and this is the length. Okay. Got it. How about others? Who all are there? Let me. Anil, Abhijit, you got it? Kayashri, Vinayak, Rishikesh. These are all very basic concepts. If you have doubts, you can please ask. See, there is type 4 as well, but hardly people use, so I can ignore. Okay, now that we are good with this, okay, we completed this slide. Okay, let's go to one more slide, data integrity. And data integrity is fairly simple. Okay, just be with me and you will understand. So data integrity refers to the validity of data, meaning data should be consistent and correct. This garbage in, garbage out if there is no data integrity. So we can enforce data. What I'm trying to say is integrity. Okay. What is integrity? Integrity is amalgamation. Amalgamation means like gluing everything and making sure they are intact. Okay. For example, you have date ID here. Or come again with the product ID. Product ID is here. Okay. In product ID, there are 10 products. Okay. Here also there are 10 products. Now that a person, there's a one more new product that has come here. Okay. And they have just added that in the fact sales table. Okay. But that is not added as part of dim product table. Now what happens? There will be an issue, right? Here you have product ID 11, but here they were not added. So there is no data integrity between two. If you add that 11 product here also, then there is integrity between these two. So you make sure that data is consistent and correct across all the relationships, whatever, whichever tables are used. Okay, sure. Consider these two tables, okay? This and this table. Or let's take the same. Just give me 2 minutes.